Thank you, Ratul. Yes, welcome to the panel. I'm Simon Peter, Full-Site Co-Director and also faculty in the Allen School. And yes, I'd like to invite Thomas, Matt, Abhishek, and Surjan back onto the panel. I know that I asked the panelists ahead of time to think of the important takeaways, and we're going to get to that first, but I think we actually have a number of really interesting questions that I would like to get to first. Don't worry, we're going to get to your takeaways as well. And in fact, the first thing that came up that I thought was striking to me was that effectively if I think about the structure and the architecture of these different service meshes, the hyperscalers, in this case Google and Meta, decided to go with a library-based approach, while the kind of from scratch approaches decided to use other architectures. And then there's Surjan, who has another new architecture on top of that. And I wanted to kind of compare and contrast a little bit and maybe also put a bit of a timeline onto this. So if I pegged the timeline to 2015 as the kind of genesis of Envoy, I would like to see if each one of you could speak to when you designed your service mesh architecture. What time was it? What was the predominant use case that you had in mind at that time? And perhaps also, how has that use case changed for you over time? And do you wish now that perhaps you would have chosen a slightly different architecture? Or do you see your architecture kind of moving over to a slightly different way to be built? And I think I'd like to start here with Abhishek over at Google's side.
Sure. Even though I went over the history, the answer to this one is a little vague. So I'll try to speak directly to your question. The predominant use case, especially in the mesh context, I would say, is load balancing, in my opinion. Load balancing was a very early need, and back in 2007 when I joined Google, they were already doing some amount of load balancing in the RPC layer. Over time, the one difference was we would not consider it mesh the way it is today, because the configuration was all done purely by the client. So the client team would talk to the server team and figure out what was a reasonable load balancing approach, and then you'd go hard code it all in your client, and that's the way it would work. In the early 2010s, we were already looking at, there were some higher level control planes. A GSLB paper was published by Google, I think, in the neighborhood of 2011 to 2012, which provides load balancing at the global scale, picking between regions and zones. And we were trying to take this load balancing configuration, which was purely done by the clients, and put it into a centralized control plane. So if we were to try and think of that as the genesis of when we were really starting to think of it as a service mesh, it kind of went through various fits and starts. Other things like health checking, etc., which are also mesh features, were also built in the early 2010s as sort of standalone control plane features instead of being purely client server. And we certainly experimented with the sidecar or proxy based architecture, and actually back in 2013 2014 built something that looked very similar, if you squint at it, very similar to the MRPC discussion of like use shared memory to go into a separate process and then have all the networking in that process. And some of those things didn't work out because of the performance needs of the user base were not met by what the team was able to accomplish in that architecture. But it's been a decade, so I think it's great that researchers are exploring that part of the design space again. And of course, with the advent of cloud, gRPC, and traffic director based service mesh control plane, these are relatively new. These are all things that have really been built over the past 4 to 5 years. And really the service mesh features in their current form with a centralized control plane that speaks XDS and provides all of it together as a package is sort of the latest evolution, which I would say is the past 3 years.
That speaks to people moving up the stack over time. It seems that you have these features that you provided first at the kind of lower levels, and then eventually you had to migrate up a bit and provide more feature-rich abstractions on top.
Right, and a very quick comment on load balancing, because we actually kind of, there's a pendulum that swings. It was earlier RPC layers did it purely on the client side, as I mentioned. In early days of gRPC, we tried to push it all into the control plane, way more than even XDS does. And we built something called gRPC LB, which shipped with gRPC, where all of the load balancing decision was done by the control plane down to a very, very fine granularity. And the client could be much more dumb and didn't really have to have much logic at all for processing the load balancing updates. But that ended up being a little too brittle and a little too hard for people to transition to. And now the pendulum has kind of swung at least halfway back. We still have the control plane, the XDS controller, but a lot of the functionality is actually implemented on the client side. It's just that it's not configured locally and comes configured from the control plane.
Thank you. And I'm going to take it to Matt next. Say a bit more. I know you already said quite a bit, so maybe we can keep that short, but maybe say a bit more about the genesis of Envoy. What features were you longing for that did just simply not exist at the time that you felt you needed to build from scratch, and how has that changed?
I think the initial focus was definitely observability related. Just because at the time, even if you look at the competing systems that were in place, whether it be HA Proxy or Nginx primarily, from just an observation standpoint, like logging, tracing, metrics, the output that those systems provided at the time were, I would say, fairly primitive. Of course, once we had that in place, we, then, as I said before, we went into a lot of the load balancing features and fault features. But, coming back to, I think, the crux of your question about sidecar versus library, or, that whole question, as I said before, I think the sidecar is a unfortunate hack that is being unwound at this point, whether there's stuff that folks like Tomas are doing in kernel, or just moving into some of the underlying platform systems. And no offense to the gRPC folks on the call, but I continue to believe that the library-based solution is a really poor choice for most people. If you're a hyperscaler, that's fine. Like, you can probably have a team of people who can maintain libraries and get them upgraded and all of those things. But for the vast majority of organizations, asking them to maintain multiple libraries or do library upgrades or that type of thing, it's just really a non-starter. So having some system where you can provide as much functionality as possible is, outside of process, is worthwhile. And all of the complaints, that people have about sidecars and memory usage and CPU and on and on and on, I mean, they're all justified. As I like to say, there's no free lunch in computing, so you have to pay for it one way or the other. And I think a lot of these arguments are disingenuous sometimes, just in the sense that you can have CPU in a sidecar, you can move it in process, and yes, there's some overhead from going in process to the sidecar, but you're just shifting a bunch of the CPU from the sidecar to in process. So it's not like a one-to-one switch. So I think a lot of these conversations lack nuance. And again, no offense to the folks on this call, but I mean, this area, the level of FUD and fighting with the vendors, it is like unbelievable. And I would not believe what they all tell you, because they're lying a lot. So there you go.
Yes, that speaks a lot to the kind of heterogeneity that you have to deal with when you start from scratch, as opposed to kind of the hyperscaler approach. I like that a lot. I also like that you said you started kind of from observability and then built load balancing in as a kind of second feature, whereas it seems that from the hyperscaler's perspective, it started with load balancing, and then observability was the kind of secondary aspect that came later. How did that look for you, Thomas?
Our entry point was definitely on the layer 7 security side, so layer 7 authorization, like the typical bringing the next gen firewall into east-west. That was the initial starting point. We quickly learned that that was a little bit early and observability was needed first. I think we saw a lot of customers still using or being bound to application instrumentation based solutions, and they wanted something transparent that works across all applications. That was an initial focus point, still very security focused. And then the multi-cluster, kind of the or multi-cloud approach, so going beyond the scope of a single cluster, so the cluster mesh feature was very popular. We didn't call it a service mesh back then. We knew about service mesh, but to us that actually looked very different because that was always using proxies, and that didn't make always sense to us. So we didn't actually call it a service mesh until very late, when we started implementing some of the missing functionalities, such as retries, some of the layer 7 rate limiting, which I think is less demanded on the enterprise side and more demanded on like the modern microservice side, where you actually have some of these problems where you can shoot yourself in the foot and need circuit break and rate limiting and so on. Enterprises often still just struggle with, let me get some basic observability beyond SFlow, NetFlow. They're operating on a completely different level. So it really came up from like a completely different world. I agree with Matt. Sorry, some of the discussions are very entertaining, and in the end, I think what matters is what users are saying, right? And I think the beauty about open source is that it's very visible what is being used. It's very visible how Envoy is being used very widely. It's very visible how Cilium is being used very widely. That doesn't mean that there is one single solution that works for everybody, right? I think the library-based approach works really well for some, will not work for a die-hard enterprise, which is not fly, but will work really well if you control your apps and you need the last bit of kind of speed and so on. So to me, I think this is a lot less philosophical than it sometimes appears. I think some of the use cases are actually very different, but we try to bring everything together into kind of one big service mesh umbrella, which not always works. And I think maybe that also speaks to what Matt said. There may not be this one single centralized service mesh control plane that unifies it all. The use case and the needs are just quite different. Some
right.
based on the actual user.
Right. Yeah, I see the focus for you, especially kind of was the starting focus was security. And I want to get back to that in just a little bit. But I'd like to give Sergeant a chance to talk about his approach as well, which to me is kind of an entirely different way to look at service meshes. So I wonder, how did it start for you, Sergeant, and where do you think it's going to go? Okay, while Sergeant is figuring out technical difficulties, maybe I'll get quickly back to that security and architectural model, because I think one thing that we didn't get a lot of time to talk about were kind of more or newer hardware offload ways to think about service meshes, and those could obviously have security issues. And Sergeant is back. Maybe we'll switch briefly back before I go.
Okay, thank you. Yeah.
Yes,
so,
excellent.
Yeah. So in particular, we have a lot of freedom to design the network layer as much as we want because the user basically programs at a level higher than that. So we could have gone with the sidecar, we could have gone with gRPC. In the end, we went with a custom TCP-based protocol for performance reasons. And yeah, same reason why we didn't use a sidecar, even though, I mean, we're still very early and we could, we can make any choices we want, but once we get more usage, we'll have to reevaluate. But yeah, I don't have a strong opinion on like whether to sidecar or not to sidecar. I think an argument for sidecars is that most people don't care about performance. That is our early impression of talking to customers, is that just get me something that works and gives me enough features. So there's that, but then companies like Google and Meta care about performance, but those are pretty rare. So yeah, it's a tricky question, and one that we don't really have an answer to. Yeah. But I would say the vast majority of people don't care about performance, but those that do, they they do. So then, I feel like they, you've seen recent news about Amazon Prime Video. They've Cloud Function. Everything is great. Everything is simple, but you end up spending 90% of your cost on moving bytes around. Then you really you need an alternative. So they went with Monolith, which is kind of interesting for us. I thought that was it's like don't use microservices. Very strong don't use microservices message, and yeah, it's interesting.
Just briefly, for you, what would you say is your most important application, your most important use case right now? Given that you're just starting, you probably have something in mind.
Yeah, so I think that we have a very small set of people that we actually, our biggest challenge right now is that people are asking us, don't automate things for me. They're worried about the framework side of things. There are a lot of engineers out there who don't want, learn timeouts and, don't put any AI in my application. That was a question I posed to Matt, is that we see actually, engineers who maintain a service, they want to be able to control things. I mean, of course, it's kind of illusion of control, but yeah, for us, the biggest challenge is that are like, I don't want you guys to do weird things under the hood. Like, I want to be able to know if I send this byte packet, it reaches the other end. If there's any issues, I can sort of understand them. But yeah, actually, I have a question for Matt or Thomas about, what is your experience with people wanting to control things versus, you doing things on their behalf so they don't have to? That you guys, what's your opinion on that?
I mean, my experience is almost universally that leads to bad outcomes. Mostly because people might commit to configuring something on day one. The problem is that in these systems, things are always changing, right? I mean, they're changing constantly. And what we see, or at least what I've seen, is that people do not reconfigure those things, whether those be timeouts or circuit breakers, or the list goes on and on and on. And I don't work operationally on this very much anymore, but I spent years in some form trying to figure out some trade-off of allowing people to, okay, like you're going to do some background inference, and then you're going to like tell people recommendations, and then they're going to apply them. Like no one, I mean, like they just, like, they don't listen, they don't do it. So I think it's impossible. So I've come full circle to the extent that now when I tell people for new Envoy deployments, we have adaptive versions of most of the naive things. So like circuit breakers and those types of things. We have admission controllers, which do some like adaptive amount of back off based on success rate. We have like automatic outlier detection. We have all of these things. And at least for me, I strongly recommend that people start with those systems because they should work well enough and they do not have to be tuned. So like in general, I would tell people to always use something that does not have to be actively tuned because no one ever tunes it. That's just my personal experience.
It's very interesting. Early adopters of a technology always create snowflakes. And then day 2, day 3, you realize how expensive it is to maintain these snowflakes. So even early adopters eventually want to standardize. And I think that's what we're seeing right now. We're still seeing a wide range of different demands though, because sometimes you shoot yourself in the foot and you need that flexibility. For example, you have a couple of customers, they need to funnel TCP through an HTTP proxy. So they're using Envoy to embed TCP and HTTP, funnel it through, decapsulate it later on again. You cannot do that with Gateway API or some standard. You need to at least get to some lower level configuration. That's a kind of a semi-snowflake, but then you don't want to necessarily build your entire mesh strategy on needing that level of control. That's why I think it's important to offer different levels of abstractions that you can be as standardized as possible and only kind of go away from that standard when needed.
Abhishek, are there low and high level abstractions in gRPC? How do you view the kind of problems of special snowflakes and configurability.
I actually agree with Matt a lot on people not necessarily caring about being very diligent in fine tuning their controls to the extent they are. I also feel like that's a space where there's still a lot of open problems, right? Like load balancing. What's the objective? Are you trying to just balance out CPU utilization on your servers? Are you trying to optimize for latency as observed by the client? People actually, if you start digging into it, um, people's expectations are different from something as simple as load balancing, and we don't have very good sort of well researched consensus solutions for a lot of these things, and they're sort of best practices or something that a vendor puts in and everyone kind of just goes through it. But I do feel like the research community here could um, actually move the entire industry forward by taking things like load balancing and circuit breaking and some of these other things where we are, on the one hand, there's a clear need for them. On the other hand, the diversity of use cases is enough that we don't have necessarily an out of the box solution that we can just say that yes, this has been like well studied and proven that it's going to work for every single use case you might have.
Yeah, I just want to echo that very, very strongly. Is that I think that in general, everything to the extent possible has to be automated, and it has to be transparent. And in the load balancing space, when it comes to timeouts and retry policies and all of these things, I think organizations have taken a run at inference and like a run at trying to figure this stuff out, but it is not a solved problem. So I completely agree that from a research perspective, this is a ample area of research that I would love to see more progress on.
Okay.
So yeah, I'll give you an example. We had the previous, actually we have an internal framework that we've been working on, and we have this learning, we put in this little learning loop that determines whether to send the packet right away or to wait a few hundred maybe microseconds for more data to come to send more data together, which is more CPU efficient. And our biggest user, which is web search, said, please don't do this because I think it's a fear. I don't know if it's a rational fear, but when things break, they want to be able to understand what happened. And if they go to a setting and it's, oh, this thing learned to wait all the time, and suddenly you have our latency goes up. I think this goes back to Abhishek's point that I feel like it's hard. It's mentally also hard, but operationally, people want to be able to understand why the system did what it did. And we've faced a lot of pushback on a lot of these simplifying, learning features. I want to share that. I'm not making a stamp. I would love for it to be a solved problem. But even if it's a solved problem, people like to be able to understand why the system did what it did. And I don't understand, is this like a mental roadblock or anyways, yeah, we don't have.
I was just going to say, I think that's true. I just want to point out, it's probably obvious that Google engineers that work on search are a very poor approximation of the average engineer within the industry. Very, very poor, right?
In terms of needs, yeah.
So it's not to say that that's not a valid concern. It certainly is. I'm just saying that when we're looking at these solutions, the problem, what makes this so difficult, and we see this with Envoy also, is that there's a lot of populations of users, right? It's like I joke about this I joke about this very often, where I'm told frequently that Envoy has like the best documentation of any project that they've ever seen. And then I'm also told that it has the worst documentation of any project that I've ever seen, right? So it's like, how do you reconcile that, other than to say that there's lots of people out there that learn and do things in different ways? And that's what's actually so hard about this, is I trying to have one solution that works for everyone. everyone is like almost impossible. And I've just come to realize that it has, as Tomas said, it has to be layers of complexity where, you know, the average person gets like feature set X, and then maybe you can, you know, undo the next level or something like that. And I think as an industry, we've done a poor job of that so far.
Great. So that was excellent. It's also, I think, great to see good consensus here on what should be done next, and having something that is perhaps a bit more declarative and then allows users to specify what they want without having to necessarily specify all the details of it, but while still be able to get observability of the details, I think is very interesting. I do want to be cognizant of the time. So nominally we would end in a couple of minutes, and I know that the panelists probably have other things they need to go do. I think at this point might just open it up and see if we can take a question from the audience, if there are any open questions. So I'll just wait here for a couple seconds to see. People could just unmute and ask or raise hands. Karthik.
Hey, yeah, so one thing, I'm from Microsoft and I'm the Azure team. For a lot of these things we're talking about, I'm wondering, like, how can a CDN help out in these things, or how can CDN be used in an application-defined networking use cases go?
Okay, so just it was a bit hard to hear, so I'm just going to repeat though. How would the service meshes work for each one of you in a kind of CDN environment?
Maybe can we specify, are we talking Cloudflare CDN or build your own CDN? Or maybe Karthik, you can specify that a bit more.
Yeah, you know, using existing CDNs like, you know, Azure Front Door or Cloudflare or Akamai, things like that, right? Further extending the network functions and moving them away from the regions and bringing them closer to the users, right?
Yeah, I can speak how Cilium with the help of Envoy solves that. It's actually more common in particular in the enterprise world than we kind of expected. There's often already existing relationships in place, whether it's Akamai or Cloudflare or something as part of a compliance program. And often they ask is, can we get network traffic, either ingress or egress, through those existing CDN solutions? They often also offer bring your own IP solutions, so they can even be considered from an IP addressing perspective as part of the native infrastructure. So we actually offer proxy redirection not only to an Envoy running on the node, but also to, let's say, a Cloudflare proxy. And optionally offer embedding TCP and HTTP to, for example, egress all TCP traffic through an HTTP proxy at Cloudflare. That was one of the examples where standardization may not happen because it's a bit of a niche use case, but Envoy does offer this capability, and it's definitely a need of enterprises that want to be both cloud native but also have old school compliance requirements that often require these hacks and this kind of infrastructure hacks. And then of course telcos, like this is super common. They call this service function chaining, where we use all sorts of different protocols to funnel traffic to functions, whether that's in the own network or as part of a CDN. Could be Cloudflare, but could also be CDN functionality that's hosted in the data center itself. So definitely that, from our perspective, we consider that part of a network mesh. It may not be part of like a traditional service mesh.
Got it.
If there's anyone else wanting to take the question as well. Abhishek, do you have deployments in CDNs?
That is interesting. We do have an edge network, and we have extended some of the features that you typically consider service mesh features. I mean, most of the time when we talk about service mesh, we talk about, like, we think of a cloud or data center type environment where a lot of service to service communication is happening. But if you sort of generalize the definition to include applications running all the way onto like user devices, things that come into mind are authentication and authorization functionality, and then of course the core value of CDNs is in a way a distributed cache, and you can but like I think to the extent that I have seen it used with Google, Google sort of internal use cases is primarily around authentication, authorization, cache freshness, and things like that.
We can maybe take one more. We started a little late, so try to see if there's one more question from the audience.
I have a question.
Go ahead.
So how are you guys thinking of security? Like, what are some of the emerging security problems or questions? One of the things I noticed was kind of a primary focus on ACL. And so how are you thinking of information flow security? If there's potentially a service that's malicious, how do you guarantee the security? And then kind of related to that question, like, is there a way to do like property testing on a service mesh configuration to say something at runtime, like about how safe potential integration is?
I can speak to that, but I don't want to be the first one again.
I can start if you want.
Go ahead, Matt.
Look, I think that with all of these technologies, as I said before, I think they're toolboxes that can do a variety of things, right? So authentication, authorization, and this is, again, comes back to, I think, like the underlying point of some of the things that we've talked about is that there is not a one size fits all solution for everyone out there. And to give you a concrete example, in the last 5 years, there's a ton of verbiage and FUD and talking about zero trust networking, right? So it's like, it's all the rage that we're going to do TLS between services and all of those things. And let me be honest, if you're Google and that's your last line of defense for defense in depth, that's great. That makes sense. But if you look at the average organization, like zero trust networking is so far down the list of the problems that they face in terms of application security and everything else, that I actually think it's hugely distracting for us to tell people that, like, you should encrypt all the data between your services and do all of these things. It's like, let's focus on the basics here. Let's focus on basic application security. So I don't have a great answer here other than to say that something like Envoy, it can enable us to build toolboxes that can more easily do things like mutual TLS or JWT token authentication or external authorization or OAuth or OIDC or all of those things. But it's up to us to, I think, to compose it at a platform layer in a way that makes sense for people. So this is unfortunately yet another area where I think we have great tools. I don't really think we have a holistic solution yet for people.
Thomas, do you have to add to that? More security-minded answer?
Well, I mean, I agree too. Like, I agree with Matt from a practical perspective. I think most companies have way bigger problems than encrypting all the network traffic. Often this is simply compliance driven, and they need to encrypt in order to be compliant. And if a CISO saying like this is more important, it's like from a practical perspective, or like the complexity it adds may not offer the best return. I would say. That said, for if infrastructure is really important to you and if it really matters, then of course an MTLS model can bring significant advantages compared to just a pure network segmentation level. Overall, it's like high level, I would say, we see a lot of demand for all sorts of network related security features being requested of our mesh, right? Whether it's WAF, URL categorization, access logging, authorization, authentication, all sorts of, I think we almost see demand for what used to be a variety of different vendor products and different open source projects, all getting into whether we call it mesh or application networking, this new unified network layer that is now supposed to do it all. It's not the first time we're trying to do that as part of the networking vendor ecosystem, but the demand is always there. Fewer vendors, better integration, one layer should do it all. Like the ask from the customers is always there. Whether zero trust, I mean, I will not even say anything about zero trust security. If you're trying to do security without the zero trust approach, you're definitely in the wrong. You're definitely in the wrong.
Excellent. Sergeant, you have your hand up.
Yeah, I was just because I'm going through the process of adding MTLS support to our protocol. I've learned that security is a spectrum, and at least at Google, our security teams go from you could secure the network, but then what about the processes on the same VM? Are they secure? And what about then you have to worry about moving processes on physically different machines, but then what if they're owned by the same user? I mean, you can just go absolutely insano on security, and you will not feel secure by the end of it. It's just saying, okay, we'll just secure the protocol. Will you do MTLS? Doesn't guarantee anything, really. I mean, it guarantees some things. It makes it slightly more difficult to attack an application, but yeah, if you really care about security, you have to invest in a lot of other things. I mean, yeah, if the attacker takes over a process on a machine and can suddenly jump into other processes, then what are you going to do? And how do you secure against that? It's very difficult. So yeah, it's a huge spectrum of attack possibilities out there. So just MTLS, I feel like, is not enough.
I think Thomas, overall, you're in agreement with that. I'm not sure if you wanted to respond.
So I think, to me, I see it. I mean, I really have this heavy enterprise background, right? So I think I almost feel like I'm living in a completely different world than some of the others here on this panel. What we typically find ourselves in a situation where it's not really the customer deciding what they need; they're being told what they need to do. Right? It's not necessarily about, let's find the best potential security model. It's literally like, you need this, and like the compliance requirements require this, and they know it's not necessarily the best next step, but there's just no other way, which then leads to a hack built on the top of another hack to somehow make it work, right? Enterprise infrastructure never looks pretty. It's never green. It's like this brown mess of layer above layer above layer with 30-year-old apps, somehow still some COBOL flying around, right? And somehow it needs to be secure enough, right? And somehow everybody wants to keep their job. So it's often just about finding solution. It's rarely about finding like the best model. But then at the same time, these people also go to KubeCon and they see cloud native zero trust security of MTLS, and they also want some of that. So in the end, there's always like some modern approaches in this mix as well. So it's just interesting, but never as simple as in a greenfield environment, of course.
Yes, very true. There's a difference between the kind of research goal of security and the business case for security. That makes perfect sense. So I want to be mindful of the time yet again, and maybe take the time now to the panelists. If you have any closing statements, anything that you think we didn't talk about that we should talk about, any research message or otherwise that you would like to give to the students that are in the audience, now is your chance. I know that we already addressed the kind of things should be easier to configure for the users question. I wonder, there's great consensus on that, but I wonder if there are additional things. Sergeant has the hand up.
Yeah, thanks. I think one thing that's new for me, I've always worked on things inside Google, and it's kind of easy to know your customer, you know what to design. This is my first foray into the open source world, and I've realized that nobody understands who the user is, what the user wants, and it's difficult. Like Matt said, there's so many different types of users, and there's so many different kinds of features you need to add to your system. And yeah, it's a really challenging world out there. I don't think there's a single solution fits all. And yeah, and people often don't know what they want, what they don't want. They hear this something and then they form opinions. Yeah, it's a messier world than I expected, for sure.
I was just going to joke that you'll know that you're successful when people are yelling at you constantly. So if you reach that level, then you have found open source success.
Thank you. Yeah, so I would love to hear your open source stories, actually, if anyone has any. For us, that would be useful because we're just first time starting. So maybe, how do you keep, how do you manage?
Maybe Thomas and Abhishek can weave that into their closing statement.
Yeah, absolutely. So I actually wanted to include the open source part. As appealing the generative AI aspect might be right now for students, who've been spending 20 plus years in infrastructure and open source, and it has been very rewarding. I think both from a new problems getting thrown out there to be solved, while at the same time the whole field not constantly changing. So there's also, I think, a steady state of just kind of things staying the same, which can be helpful at times. What has been fascinating to me, and I think what I would encourage everybody to do, is really to go the open source route. It can require a thick skin at times, in particular if you achieve the maintainer fame of math, right? I think then you can simply not make everybody happy at some point anymore. And even worse, you will make some people unhappy, or even worse, you may have competitors that will specifically want to make you unhappy. But that's not an entry level for open source engagement at all. I think the majority of open source communities are very healthy, and I think it's a great way to learn, and it's a great way to engage with others in the field that have years of experience, where you can learn very, very quickly. I was fortunate earlier in my career to join Red Hat and work on the kernel, and I don't think I could have learned as much ever if I didn't have this open source experience and this ability to see the work of hundreds of others and learn from it, and just learn and grow as quickly as possible. The closest next thing might be, oh, my light just went out. Closest best next thing could be working inside a big corp like Google, where you can see a lot of others. If you don't have that opportunity, I think open source is probably the best next thing.
Very true, very true. Just quickly, any open research questions that you would like to add before I go to Abhishek? Not sure if Thomas heard.
I can add. So I think we've
Okay.
we've been playing around with like automatic job placement and resource management, and these all seem like really super fun research ideas, because for us we deploy the whole app so we can place things automatically and so on. It's a very interesting research topic, but I think it feels research for now. I don't know how much people care, or how much they would enjoy those types of features. Again, I'm coming back to the automation part.
Mm-hmm. Right.
Yeah, it's sometimes a real struggle to actually design features that are not driven by the user. And in the academic community, you guys have the freedom to do it without that requirement, and I really do miss that. So just do crazy stuff, and hopefully it'll get used. But in the real world, some of these more advanced, interesting research ideas, people just don't care, in my opinion.
Mm-hmm. Abhishek, do you want to add? Yes, go ahead.
Yeah, I wanted to throw out a couple of interesting research problems. So one of the things we are doing in the service mesh space is we are reinventing some of the things that, I have a networking background. So in the networking world, people invented things at layers 3 and 4, and some of those things or some of the same problems are being solved at the higher layers. And what happens is those older solutions don't go away, and being able to sort of stack them properly or do cross-layer optimization. I'll give you an example, retries, right? Like you have the TCP layer trying to retransmit packets. You have something that's trying to reestablish connections. You have an application that's configured to retry its RPCs. All of these retries are kind of sort of operating independently, and you hope that the entire layer cake is aligned in what it's trying to achieve. But thinking cross stack might lead to some fruitful ideas. Another example would be we spent some time talking about security. You have these L3 notions of firewalls and perimeters, And now you have this layer 7-ish notions of who's allowed to talk to whom through MTLS and so on. And how do we actually combine these things together? Because both internally at Google and with cloud customers, one of the things I see is, the security requirements come from 10 different directions. You have a regulator telling you one thing, you have a customer wanting another thing, you have an internal security team wanting a third thing. And if you can very quickly get tied up into like building something so complicated that you can't reason about it properly. And I think there's room to really think about all these things in a joint fashion and come up with some interesting solutions.
Thomas.
I have one more research idea because it's a problem that many have attempted and has not been solved yet. I think it's a problem that could be solved, and in theory at least, and it would be not only incredibly valuable but also very interesting to solve. It's the ability to completely transparently correlate incoming requests into a service with the outgoing services in a completely application agnostic way, and without doing any sort of time-based correlation. It's a problem that has been attempted numerous times. I have tried to solve it as well. Whoever comes up with a solution will be a very famous person.
Excellent.
I would say that it's probably impossible, but figuring out a way to make it better from a framework or a protocol perspective would actually be cool. So if you're researching new protocols and somehow you can force there to be a correlation ID, that alone would be great.
So this has been great. I just got a message from the showrunner that we have to end soon. So these were great research directions. We're kind of crossing security, cross-stack optimizations, declarative interfaces, being able to deal with a whole bunch of yelling. All of these were great. So I'd like to thank the panelists. I'd like to thank the workshop attendees. I think it's been great. I hope you took something away from the workshop. And we're happy for your feedback. Maybe we can run another iteration in the future. So thanks very much.
Thank you.
Thanks,
Bye.
everybody.
Thanks.